If all you wanted was another simple tutorial, then you'd be better off somewhere else. This is not just another PowerPoint presentation. Neither is it endless lines of config scrolling past your eyes. No, I'm sorry to say that this is not the video you'll be watching. This is a cautionary tale about routing and VPC. I bring this to light in hopes that you can avoid the pitfalls yourself. Early in 2017, a colleague and I were given the task of installing a new pair of Nexus switches into a production data center. This included migrating a few VPC-attached routers and firewalls. No problem, we can do that. There'll be a small outage, but how bad can it be? So I planned it out, configured the switches, and prepared myself to spend a night in the data center. During the migration, we saw something strange. The routers and firewalls weren't peering with the switches. The routers were up, and we could ping them, but OSPF peering was unstable. Let me use a lab demo to show you what was happening. VPC has already been configured on a pair of Nexus 9000 switches, and it is working correctly. There are two routers connected with VPC. As you can see, there is nothing special about the VPC configuration. It is all quite normal. On the OSPF side, switch 1 is peering with 3 different neighbors. It is peering with switch 2 twice in this example. Switch 2, however, has problems. It is peering with switch 1, but the two routers are stuck in init and xstart. If we debug the OSPF adjacencies, we can see that the neighbors are looping between init and xstart. The routers would show similar errors in their debugs. We spent hours troubleshooting through the night, but we couldn't find the cause of the problem. Finally, the time came. The decision has been made. We began to implement the rollback plan.
Hello, darkness, my old friend.
We later returned to the office and put some thought into it. After a couple of days of research and testing, we finally found our solution. To understand what causes this issue, we first need to have a quick review of lags and VPC. A lag is a bundle of several physical links connecting two devices. Each flow of traffic gets assigned to one of the physical links. A VPC is an enhanced lag, where 2 Nexus switches are used instead of 1. Each flow of traffic is still assigned to one link in the VPC. Sometimes traffic meant for switch 1 will arrive on switch 2. Switch 2 can have a feature enabled called peer gateway. This lets it respond on switch 1's behalf. So how does this fit into our problem? To answer this, we need to have a high-level overview of how routing protocols interact with VPC. Routing protocols, aside from BGP, expect routers to be directly connected. To enforce this, their packets are sent with a TTL of 1. Throughout the process of forming neighbors, a series of multicast and unicast packets are sent. If switch 2 receives some of the packets meant for switch 1, it naturally decrements the TTL. The TTL is now 0 and the packet is discarded. This causes the neighbor relationship to not form completely. Next, we'll have a look at some ways to solve this problem. All of this so far has just been for a router peering with the Nexus over VPC. As Cisco's routing over VPC document shows, there are some other topologies that we must consider. The exact behavior will depend on your Nexus platform, so be sure to use their document when designing your solution. The first topology we'll consider is where the routers want to peer with each other. The routers are connected to the switches with VPC. This scenario works as the routers are directly connected at layer 2. The switches do not decrement the TTL of the peering traffic. The switches are not peering with anything in this topology. They are used only for transport. But what if you want your switches to participate in dynamic routing? In this topology, the router does not use VPC. Instead, it is connected to an orphan port. If you want to peer with both switches, you may need to add an additional layer 2 interswitch link. This depends on your platform, so check the routing over VPC document. If you do need this link, the VLAN used for peering would need to be pruned from the peer link to force peering traffic over the new link. Of course, you can use a hybrid approach. In this topology, a router peers with one or both switches over an orphan port. It is also able to peer with the VPC connected router. An alternative is to change the links to routed ports with the no switch port command. These are still orphan ports and allow the routers to peer with the switches. Now the routers are more than one hop away from each other. They can no longer peer with each other. There are some times when the previous out-of-the-box solutions won't work. Imagine a case where you have a cluster of ASAs. The recommended way to attach these is with VSS or VPC. There are a few options here. First, think about whether you really need dynamic routing. If the cluster is on the edge of the network, you may only need a default route outbound and some static routes inbound. If you do need dynamic routing, you may consider running BGP. In many cases, this may not be an ideal solution, as it would need to be tuned, and you will probably need redistribution into another routing protocol. There is one final option, and I think this is the one you've been waiting for. Let me show you this one in the lab. As you probably remember, this is a very standard VPC config. VPC itself is working and the interfaces are up. Now for the magic command. In the VPC config, we add the layer 3 peer router command on both sides. This enables VPC connected routers to peer with the switches. We can now see that the OSPF relationships are stable on both switches. This is a simple solution, but there is also a simple catch. You need the right NXOS version, and if you have line cards, there are also some hardware constraints. Make sure to check out Cisco's Routing over VPC document to see what is supported for your platform. That's it for routing over VPC. I hope this will help you avoid the problems that I encountered at the beginning of the video. If you want to know more about VPC, I recommend the How VPC Works and VPC Configuration videos. If you still want more, head over to networkdirection.net. Please remember to subscribe or use Twitter to be notified of new content.